LUN provisioning is the act of allocating storage to hosts, and sometimes we call it presenting storage to hosts. Let's take a quick look at how it works with a few pictures. On the slide we've got a storage array on the right with 4 front-end ports, 1, 2, 3 and 4. On the left we've got a couple of hosts. Now let's add some volumes to the storage array. As we can see now, we've got 3 volumes, blue 1, green 1 and green 2. I've shortened those to B1, G1 and G2 on the slide, but I'll refer to them as blue and green just because B and G kind of sound the same. Next, we map these LUNs to front-end ports. In our example, we've mapped blue 1 to the odd-numbered ports, ports 1 and 3, and we've mapped the green LUNs to the even-numbered ports, ports 2 and 4, and we call this process mapping, and a volume mapped to a front-end port is usually called a LUN. Anyway, now let's connect our top host on the diagram to ports 1 and 3, and next we'll connect the bottom host to ports 2 and 4. And in a simple configuration like this, with no LUN masking or no access control on the array's ports, our top host will be able to see LUN blue 1 and the bottom host will be able to see the 2 green LUNs. Pretty simple. We've now mapped our internal volumes to front-end ports so that they can be accessed by hosts, and we've connected hosts so that they can access these LUNs. Now let's have a quick look at multipathing. Multipathing is a host-based concept that's got several benefits. First up, it allows a LUN to be accessed over multiple paths. Let's say each of our hosts on the slide has got 2 HBA cards. HBA1 in the top host is connected to port 1 on the array, and HBA2 in the same host is connected to port 3 on the array. With multipathing, which we sometimes call MPIO, an acronym for Multipath I/O, with multipathing, the top host can access LUN blue 1 via both of its HBAs. And by being able to access the same LUN over multiple paths, we've got the potential for increased performance and increased resilience. Now let's look at something we call failover, or active-passive configuration. The slide now shows one of the paths from each host as a dashed line and the other as a solid line. The solid line represents an active path and the dashed line a passive path. In this active-passive mode of operation, each host only accesses LUNs over one of its 2 paths. The other path just sits there idle, and this has the knock-on effect of reducing the potential internal bandwidth within the array as well, as we show in an oversimplified picture on the slide. Basically, some internal paths on the array are used and some aren't. Now, in the event that we lose a path from one of our servers to its storage, such as the top path on the top host, the other path kicks in and takes over. But not only that, we could lose an entire controller in our array, like we're showing now in the slide, and still not lose access to our data. Now we've lost ports 1 and 2, affecting both of our attached hosts. But no big deal, right? The passive path is taken over for each host. Now let's talk about LUN masking.